So, what we've been talking about, we just did a quick intro yesterday with the conic sections. Conic sections are parts of a curve, so it's part of a cone. So we have the different parts we've talked about. We talked about ellipses, that's an oval. We talked about circles. We talked about the cone itself. We talked about a parabola, which is like a U shape, and then a hyperbola, which are like two U shapes going in opposite directions. Those are the different shapes we talked about. The Google question of the day yesterday was kind of a tough one. It was something where I just kind of left it to you guys to try, where it was stuff that we've done all previously. And it was just like a challenge question. What could you do? You had to go draw it, right? You had to figure out where two things crossed, a parabola and a line. I want to talk about that today. In fact, I'm going to bring up your Google question. I have it right here in front of me. I'm actually going to do that problem right now so you can see what I was talking about. Now again, you just had to give me an educated guess. You had no math behind it, no sciences behind it. It was just make an attempt at seeing where these things cross, right? That's what we're learning in this unit. Better ways to do this exact problem that I've been showing you, but for other shapes, circles, ellipses, hyperbolas. We're going to look at a bunch of different math. So the problem I gave you yesterday was this. It was y equals x squared plus 5x minus 6, and the other line was 2x plus 1. This is the question that I provided you guys yesterday on the Google question. And the question was, where are the point or points, plural, of intersection, where they cross? Because these are objects that are in this unit. This unit is all about lines, it's about curves, and it's about the interaction of them. So now why would you ever do something like this? This is for like an engineering or CAD program where you are trying to engineer a problem where two things are crossing, and maybe you're making cuts at certain points where you're cutting off a certain slice of an object at certain moments so that it will fabricate the right design that you need it to. That's what we're looking at. So you're looking at kind of the baby steps into like the first steps into engineering. So we're looking at points of intersection. That's kind of the main baby step. Now to do this, the first type problem, I'll draw this one in green. If you're going to draw this thing, you have to remember all the stuff we've been doing the last 2 chapters in here. Think about that. We've talked about parabolas and any type of polynomial. Like, for instance, on this top graph, I'm going to draw this in green. It has a y-intercept of -6. How I know that? To find a y-intercept for that top polynomial, you plug in zeros for all the x's. So if I plug in zeros, that's 0 squared plus 5 times 0 minus 6. Well, that's 0 plus 0 minus 6. I would hit -6. 1, 2, 3, 4, 5, 6. Yeah, so I'm hitting -6. Then, to figure out where it hits the x-axis, you'd have to factor that baby apart. So if I factor this thing apart, it'll be x and x. It'll be plus minus, because that minus sign on the back. And then I have to make a 5 in the middle with a plus minus. So I'm going to go like +6 and -1, right? That makes the 5 in the middle. +6, -1 subtracts to make 5. And so the idea here is that the points where I'm hitting the x-axis, what would represent this parenthesis? What number? -6. And what would represent this parenthesis? +1, right? That's what we did in the previous chapter. It was literally on the chapter test we did. So -6. +1. Okay, is that 6? 1, 2, 3, 4, 5. Yeah. Okay, and then I'm going to just draw this. I'm going to just do a light drawing. I'll put it in green so you can see this. So this is my parabola. Something like that. Okay, and now the other line, I'll put this maybe in like a pink color. This is just a linear function. It has a y-intercept of 1. So I'm going to start at +1 on the y-axis. Because if I plug in zeros for all my x's, it would turn out to be a 1. And then my slope is 2 over 1, right? You can always make it a fraction. It's rise 2, run 1, rise 2, run 1, rise 2, run 1, and you get the idea, and I can draw this. Okay. So the whole point of that problem was to figure out where do these things cross. Ballparking it. Right? Graphing is not an exact science. A lot of you didn't even have graph paper. You were just supposed to like kind of estimate where you think. Maybe you use Desmos. I don't know. But you're just looking at where these things crossed. Right? I can tell because decimals are way too exact not to be using Desmos. I'm not an idiot. So now, looking at the coordinates here. So if I was looking at the coordinates right there, where does it look like it's crossing?
2,
2.5, 2.5, 2.4-ish, somewhere in that range. I'll say 2.5. I like that number. So it looks like it's about 2.5, you know, ballparking it. And then this number down here, that number down there, it looks like, and I missed that curve completely, but what is that? 1, 2, 3, 4, about negative 4.5. 1, 2, 3, 4, 5, negative 6.5. So negative 4.5, 4.5, comma, negative 6.5. Just kind of ballparking where I think. Again, that is not exact. That is just guessing where I think they go. Okay, that was the idea. Now, again, maybe you didn't get there, maybe you did. These are things we've done all previously. We've talked about lines, we talked about curves, and could you put them together? Now, what I hinted at yesterday, that is not the best method of doing this problem. It's not. It's one method. You can see it's kind of messy. I had to guess where that thing was. There is a better way to do it, and that's what I want you to see today. I want you to see the better way of doing it and what we're going to learn in this unit. Now, the beauty of what we're about to do right now is something you've already done. It's completing the square. That's all we use. We use completing the square, and we'll be able to solve this problem. So it's nothing like we're learning something radically new. We're using what we learned for, 3 sections in the last chapter to accomplish a new task, to do something new for this problem. So let's walk through it. Same exact problem. I'm going to rewrite this problem again, the exact same problem. X squared plus 5x minus 6. And y equals 2x plus 1. Okay, this is the problem I just gave you. I want to show you the new way to attempt this problem. The better way to do it. So it gives you exact answers. Okay, so we're looking for points of intersection, right? Where these things cross. That means we're looking for the points where they share the x and y at the same time. They have the same x values, the same y values. That's what we're looking for. And so how you do that? If I want the y's or x's to be the same number, that means on these equations you're looking at, these y's would have to be the same digit. They're the same number. The y would be, if they're going to cross. So if those y's are the same, I can set these two equations equal to each other because the y's are the same number. So x squared plus 5x minus 6, I'm going to set that equal to the 2x plus 1 because both y's are the same number, so those two things should be the same digits. Why I'm doing this will help me find the x. I know the y's are going to match. I want to make sure the x's are matched. And if I solve this thing using completing the square, it will tell me the x's right where they cross, which is the beauty of doing this. It's the same stuff we've always done. So we're going to rearrange this thing a little bit. If I move this 2x over, what happens to it? Negative. So I'll have 5x minus 2x. So that's x squared plus 3x, right? Bring the 2x over, subtract it. If I brought this 6 across, what happens to it? Adds it. So it's 1 plus 6, which is what, 7 over there? That problem looks like what we did last week. The part for the test, where we complete the square. I've already moved the constant to the other side. What is half the middle squared? Well, what's half the middle? This is my middle number. What's half of 3? 1.5. 1.5. That's half of it. We square 1.5. You get 2.25 on a calculator. And I have to add that to both sides. Now the beauty of this, there's no leading number out front, so I don't need to multiply the 2.25 on anything. So it's just half the middle squared. So this side turns out to be this, right? And on the other side, I get 9.25. Okay? Nice, easy number. And now what we're going to do is we're going to factor this left side apart. If I factor this side apart, what is the rule that we've done?
Always half the middle.
Always half the middle. So this will be x plus 1.5. That's half the middle. Half the middle is, half of 3 is 1.5, and it's positive because it was a positive 3. On the other side, I still have the 9.25, right? We just solved this. We take the square root to the other side, right? You're going to take this power to the other side. You'll do a square root. It'll be plus or minus that number. And then I'll drag the 1.5 over. So this is x plus 1.5 is equal to plus or minus the square root of 9.25. Right, whatever that square root is. I think it's like 3.04, some weird decimal, if I remember right. And then we're gonna move that 1.5 across. So if I move that 1.5 across, it becomes a negative 1.5. Now the square root of 9.25, let's see, square root 9.25, 3.04. So what we're looking at here, we have two answers. We have negative 1.5 plus 3.04 and negative 1.5 minus 3.04. And so the numbers we're going to get, the digits we're going to get for my x's, negative 1.5 plus 3.04, I get 1.54, and that's one of my x's. And if I go negative 1.5 and I subtract 3.04, I get negative 4.54. Those are my two x numbers. So that's in my coordinates up above. My coordinates up above, these are my x's, 1.54 and negative 4.54. These are where my graphs are crossing. How do I find the y number? Plug it in. You can plug it into any equation you want. Which equation should you plug it into?
Second one.
Yeah, the second one. It's a linear function. Way easier to do it. If I plug in that 1.54 here, 1.54 times 2, and then add a 1 to it, I get 4.08. And if I plug in the negative 4.54, take that times 2, and then add 1 to it, I get negative 8.08. And what you're looking at here is the exact answer where they cross. I'm talking exact numbers where they cross. So if I go back to my drawing and we take a look at that, this was supposed to be 1.54. So it was supposed to cross kind of right in that lower region. My dot's a little bit too high. It should have been over a little bit. So I was pretty close, negative 1.5 and positive 4.5, right? That's that top coordinate. So negative 1.5 and about 4. So, and then this lower corner down here, negative 4.5, and it was supposed to be negative 8. My graph wasn't correct because I ballparked my drawing, right? I didn't even find where the lowest point of my parabola was. That was something we did in the last chapter. I could have been more exact. But negative 4.5 was really close. That's actually what we found. It was negative 4.5. So not too bad. Pretty accurate for just having, guessed at these numbers on that first drawing. Now, I did actually draw it. I put it in Desmos just so we could see it. These are the exact numbers. So a Desmos gives you the actual decimals and whatnot. So, all right. If you have not written this problem down already, I strongly recommend it, because the Google question of the day today, I give you a new parabola and I give you a new line, and I want you to try to replicate the math I just did here. The exact math I just did to find the coordinate where they cross. I'm going to leave this up on my board. For those who are at home, I'm going to leave this on here. If you've already gotten all your notes written down, maybe took a screenshot, you can go on Google, answer Google question of the day by doing this math, and tell me the coordinates that are exactly where your two new problems cross. Okay, that's what we're doing today. Okay, so for those that here, Google question should have went live. I think it went live at like 10 this morning. Because I had a couple of people from this period actually join period 3. I don't mind if you guys do that. Just let me know and I'll send you the links every day. But yeah, so I'm going to leave this up here. That's the only thing I have for you today. This is it. I'm done. I'm finished. That was 10 minutes. And you guys are free to work on wherever you want. So for those at home, you guys can log off. You guys can go work on your Google form. Have a happy Thanksgiving.
Everybody gets on at 8.